This conference will now be recorded.
Hello everyone. We will start with a problem. Then the topics that we are going to discuss today is competitive electron transfer processes, then redox reaction and electron processes, and electrochemical series, role of salt bridge, and there will be some problems also. Here the problem is saying that during the disproportionation of iodine to iodide and iodate, the ratio of iodate and iodide ions formed in alkaline media. So this ratio we have to find out. So this is disproportionation reaction. That information is already given and it is occurring in alkaline media. So iodine, that is I2, it is converted to I minus. First we will balance this reaction, that is we need to know the total balanced equation. So iodine is converted to I minus and iodine is also converted to IO3 minus, which is iodate. Now why it is disproportionation reaction, that will be clear if you focus on the oxidation number. Here it is 0, here it is minus 1, this is 0 and this is plus 5. Because total negative charge coming from oxygen is minus 6, overall negative charge is minus 1, so total positive charge must be plus 5 over I. So same species I2 is simultaneously converted to I minus, which is basically reduction. From 0 to minus 1 it is reduction, and also it is undergoing at the same time oxidation. That means from 0 to plus 5 it is oxidation. So these are the two half reactions that we will balance. Now once we get the full balanced equation, in that equation you will be able to see what is the ratio of iodate, that is IO3 minus, and iodide, and that ratio actually we have to find. So the first equation, I2 to I minus, here number of iodine in the left hand side 2, but in the right hand side it is only 1. So if I put here 2, the next thing that I have to do is charge both sides should be same. So here I will add 2 electrons. Now both sides charge is same and number of ions that is same. Now in the other side, that is I2 to IO3 minus, first of all iodine, if we equate, that is both side 2I atom. Next is oxygen number should be same both sides. So that is why I am adding here 3H2O. Now one oxygen number is same, as we have added 3 water, so there must be some total number of oxygen is 3 into 2, that means 6, so it should be 6. So 6 water molecules I have written, so it means there must be 12 H plus in the other side. But as it is alkaline medium, we cannot add H plus, so that is why to balance it both sides we will add 12 HO minus like this. So once it is done, the full equation will be I2 plus, from this part there is total 12 water molecule. Here we have 6 HO minus, 2 iodate, and 12 H2O, 6 H2O. So total 6 H2O right hand side. Next thing that I will do is total number of negative charge that is present in the left hand side, 12 negative. And in the right hand side it is basically 2 negative, right? So that is why now we have to add electron. So here we have 2 negative charge here, 2 negative, here we have 12 negative charge. So to equate the negative charge both sides, now we have to add electron. Okay, so here number of electron will be 6 H2O, so it will be 10 electron. Then it will be both sides same. Now once it is 10 electron, let me write the full equation. Iodine 12 HO minus, 2 iodate, 6 H2O and 10 electron. Now come to the other equation. Here we have only 2 electron. Here we have 10 electron. So number of electron must be same. So that is why I am multiplying this equation with 5. Now once we have done that, now finally the both equations, if I write, it will be from this side I am writing 10 electron, 5 I2, 10 I minus. And other equation we have not done any changes. Basically up to this part also if you do, it is enough to understand what will be the final ratio, because if you see here we have 10 iodide and we have 2 IO3 minus. So the ratio of iodide and iodate, it is basically 5:1. But here it is asking the ratio of iodate first, that is ratio of IO3 and I minus. So this should be 2:10, that means it is 1:5. So we have already reached our answer, but I am writing here the full equation so that it is clear completely. 2IO3 minus 6H2O and 10 electron. So 10 electron both side it is same. So remaining balanced equation should be I2 5/2, that means total 6I2. Then we have 12 HO minus 2 IO3 minus 10 iodide 6 H2. Now you can take common 2. So ultimately it will be 3 iodine, then 6 hydroxide ion, then IO3 minus, then 5I minus, and 3H2. Without doing this also we can easily understand what should be the correct answer. It is basically the first option, because see these two, the ratio is basically 1:5. So option A, that is basically the correct option. Okay. So here basically the question is all about balancing the equation. Once we balance it, we will be able to answer. Next topic we are starting competitive electron transfer reaction. So competitive electron transfer reaction means here there will be competition between two different substances. Fine. So as you can see in the picture, in the beaker we have taken copper sulfate solution, and in the copper sulfate solution we have dipped a zinc strip. So a strip of metallic zinc is placed in an aqueous solution of copper sulfate. Copper sulfate, its color is this type of blue, for about 1 hour. Now when we do so, what will happen? The strips becomes coated with reddish metallic copper. So after 1 hour, now you can see the color of copper sulfate, now it is faded. It is not so intense blue. Now it is pale. That means the amount of CO2 plus is decreased in the solution. Before the reaction, there is presence of copper 2 plus, but after it, the CO2 plus, now it is reduced to copper 0. So what type of reaction is occurring here? Here the reaction that is occurring is CuSO4, which is source of copper 2 plus. Then we have dipped zinc, and after reaction there is formation of zinc sulfate. That means now oxidation state of zinc is 2 plus and copper. So in this case, what is basically happening? Here copper is reduced to copper 0 and zinc is oxidized to 2 plus. Now if we do the reverse reaction, that is if we take some zinc sulfate solution. So we have taken here zinc sulfate solution, and now we are dipping a copper strip. So if we do so, the reverse reaction does not occur. Reverse reaction means what type of reaction we are expecting? We are expecting as if ZnSO4, then there is copper, and copper from 0 state, if we expect it will be converted to Cu2 plus, which is basically present in copper sulfate, and zinc will be reduced to 0 state. But this reaction is actually not happening. The reverse reaction is actually occurring. So it means what? The tendency of zinc metal to donate electron towards copper 2, that is high compared to the reverse process. So the electron donating tendency, it should be like this. copper has higher electron donating tendency compared to copper. Zinc has higher electron donating tendency compared to copper, which is clear from this experiment. Now, if we do another experiment, so what is this another experiment? So here we have taken this clear solution that you are seeing. It is basically silver nitrate solution, and this type of spiral wire that you are seeing, that is actually Cu. So now we are expecting the equation, that is AgNO3 Cu. Now after some time, what will be the change in the reaction medium? Now you can see this clear solution, now it is turned to some blue solution. So now basically it is CuNO3 whole 2. If we balance it, it will be 2AgNO3 and Ag. And you can also see that on this copper wire there is some deposition of silver. That means here, if we consider the oxidation number, copper is 0 before the reaction, silver is having oxidation number +1. After reaction, now copper is 2 plus and silver is 0. So here silver is basically converted to Ag. So this is reduction, and copper is donating electron towards silver and itself is oxidized to copper 2 plus. Now copper 2 plus, whether it is generated from CuSO4 or copper nitrate, it will show this type of blue color. So this indicates, and also you can see some silver is deposited. So in this case, the reverse reaction obviously will not occur. This is occurring, so how the reaction reverse one will occur? So in this case, basically the electron donating tendency of copper is higher than silver. Now if you combine the results of both the experiment, in the previous case we have seen that zinc is having more tendency. Now you are seeing that copper is having more tendency. So if you combine these two results, what we will see, that first it is zinc which is having more tendency to donate electron, then it is copper, then it is silver. So from the above two experimental observations, we can conclude that among these three metals, that is zinc, copper and silver, the electron donating tendency or releasing tendency is following this order. Now, this type of order, here we have only taken three metals, but there are so many metals, and if we actually want to know that which, suppose there are total 10 metals given, and if we want to know that which metal is having higher tendency, the whole order that you can get from metal activity series or electrochemical series, that we will discuss separately. But remember, this type of electron donating tendency, or you can also say that the reducing tendency. Donating tendency means what? Some species is donating electron donating, that means it is having the tendency to reduce some other species, and whether this tendency is high or low, what is the order, every information you can get from metal activity series. So this type of competition for electron release among different types of metals, it also helps us to design galvanic cell. Now in galvanic cell, what we do, suppose there is some spontaneous reaction. For example, this first experiment, if you consider, you have dipped zinc metal in copper sulfate and then it is converted to Zn sulfate and copper metal. So this type of spontaneous reaction, the chemical reaction that is occurring, we can convert this energy to electrical energy. That is conversion of chemical energy to electrical energy, and that we can do in galvanic cell. So in this case, chemical energy becomes the source of electric energy, and it is only possible for those reactions which are basically spontaneous. If you want to construct galvanic cell, suppose with the reverse reaction, that is you have dipped copper in Zn sulfate, then obviously it will not serve our purpose. We have to choose that reaction which is spontaneous. For example, these two experiments, any one you can choose. Then only we can construct galvanic cell. So next we will see how we can do so. In this case, what we have done, we have directly dipped the zinc strip in copper solution. But suppose if we can do in some other way, the same reaction we will do, but in different way. So now what is the difference we are making? The reaction between zinc strip and copper sulfate solution, it can be designed in such a way that the electrons that are transferred from zinc to copper 2 plus, this electron transfer that will not occur directly. So they will not remain in contact with each other. That is, Zn will not remain in contact with CuSO4. So how the electrons will transfer? So electrons will be transferred indirectly, and as there is no direct contact, it is necessary for us the separation of zinc metal and copper sulfate solution. They must be separate. So see, it is possible. This is the cell, how it looks. Here we have taken this zinc strip. This one is zinc strip that is dipped not in CuSO4, but it is dipped in ZnSO4. Now in dipped in ZnSO4 means what? Here we have Zn2 plus ion present, and gradually you will be getting the idea why what all these different terms. There are so many terms you can see here. Gradually everything will be clear. Just step by step proceed with me. Then in the right hand side we have another same type of arrangement, but now there is copper strip. So this is copper metal and it is dipped in Cu2 plus solution. You can take CuSO4. So now as it is CuSO4, so there must be presence of Cu plus 2 plus ion in this beaker. Okay. Now for electron transfer, that is ammeter is set up here. So it basically proves from ammeter we can understand whether how the electric energy is transferred. That is, what is the movement of electron from which side to which side, that we can understand. Now this whole setup is done in voltaic cell or galvanic cell. So galvanic cell, that is where chemical energy is converted to electrical energy. It has another name which is voltaic cell. So voltaic cell and galvanic cell both are you can use for the same purpose. Here the definition is for these two types of cell, that is basically they are serving the same purpose. There's two different names, you can use any name. So important point is chemical energy is converted to electrical energy. Now for this particular reaction, which particular reaction? This particular reaction, that is the reaction that we have considered here, that is Zn reacting with copper 2 plus itself is converted to now Zn2 plus, and copper is converted to metallic copper, that is 0 state. So if you are doing this particular reaction, I am talking about this reaction only, in galvanic cell, then the cell has a special name which is Daniell cell. So for this particular reaction, the cell is known as Daniell cell, which is basically one of the type of voltaic cell. So Daniell cell is one of the type of voltaic cell or one of the type of galvanic cell. Okay. So in this case, as you can see, what will happen? As we know, zinc has a tendency to donate electron towards Cu2 plus. So Zn will be, that is the Zn which is present in this electrode, it will liberate electron. And this electron, after liberation, there will be also generation of Zn2 plus. There is already Zn2 plus, and now the amount of Zn2 plus will increase. And these two electrons that are produced, it will be moving to through this pair, and it will go towards the other side. Now while it is going towards other side, now through this copper electron, it will be reaching ultimately this towards this copper 2 plus. It will react with this copper 2 plus, and ultimately it will reduce it to copper metal. And this copper metal, gradually what will happen? It will be deposited on the surface. Now in the left hand side, you can understand there is oxidation occurring because Zn is converted to Zn2 plus, and the electron is moving from left to right. So this is basically oxidation half cell. So where one that is full equation is this one, but if you consider the half reaction, that is why we are calling it half cell. If you consider the whole picture together, it will be the complete cell, but if you only consider the left hand side part, it will be half cell, and that is oxidation half cell. And the right hand side, copper 2 plus is accepting electron, so that is why it is reduction half cell. Fine. And both this solution of Zn sulfate and CuSO4 both are taken with same molarity. And you can also see there is a U tube, that is inverted U tube type of shape. One thing is there, and that is called as salt bridge. Now what is the role of salt bridge? That also we will discuss. So in this picture, we have electrode, that is Zn electrode, which is present in the left hand side, and copper electrode, which is present in the right hand side. Zn is dipped in ZnSO4, copper is dipped in CuSO4. Electron is moving from left hand side to right hand side, and electron movement will be clear from the ammeter. Now in both the compartments, reaction takes place at the interface of metal and this solution. So this is the metal interface and this is the solution. So this is the interface that is present between the metal and the solution. Where is actually the reaction occurring? So here, when this strip will, that is electrons will be removed from ZL, so gradually this strip, it will be reduced in size, and the amount of Zn2 plus in this solution, that will increase. So electrons, the removed electrons will pass through this interface of metal and solution by reduced and oxidized form of the same species. We are calling this same species redox couple. So redox couple means Zn and Zn2 plus, Cu and Cu2 plus. Now one couple is Zn2 plus Zn, and remember how couples are represented. They are represented like this. Zn2 plus, that is the oxidized form, is always written first. It is followed for any species, not just for Zn, it is followed for any species. Remember, always the oxidized species written first, then oblique sign, then the reduced species. Same is also true for copper 2 plus copper system. So this is called these two couple, zinc couple, Zn2 plus Zn couple. Another one is Cu2 plus Cu. Though it is true here, Zn is ultimately converted to Zn2 plus, Cu2 plus is ultimately converted to Cu. But whatever it is, you always have to write the oxidized form first, then oblique sign, and then the reduced form. That is the convention we follow. Now the solutions in the two different compartments, they are connected by a salt bridge. Now in this salt bridge, there is basically presence of some species. That is, in this part there is presence of some species. Which species? Made of solution of strong electrolyte. But don't think this is a solution which can move easily, be soluble with these two solvent. No, it is not like this. The species that is present, that is a compound that is present in the salt bridge, which is basically some strong electrolyte. What type of strong electrolyte? KCl or NaCl. Then we also take KNO3 or NH4NO3 like this. Remember here, the species is chosen in such a way so that the size of cation and anion both are very close to each other. So this type of strong electrolyte, they are mixed with some jelly-like substance, and then it is filled in this U-tube, inverted U-tube shape. So don't think whatever species is present inside this U-tube, it is never mixed with this. The role of this salt bridge we will discuss in detail. Here I am just giving you initial idea. When Zn is converted to Zn2 plus, gradually what will happen? Amount of positive charge will increase in the left hand side compartment, and when the electrons are moving here, gradually all the copper 2 plus present in the solution, it will be converted to copper. That means positive charge will decrease. Now if it is occurring in this way, there will be generation of more positive charge in the left hand side and more negative charge in the right hand side. But if this is occurring, there will be a potential, another potential difference will be generated. Now what is potential difference? When I'm saying potential difference, you can compare it. Suppose we have two tanks, and in this two tank we have some water filled up. Suppose water level is here, another tank there is water level here. So if we connect them, obviously water will flow from the higher distance to this low distance compartment. So you can also compare similarly here also. Here positive charge is more in one compartment, negative charge is more in another compartment. So there will be some potential difference generation. And because of this, some unwanted reaction may take place, but we do not want that. So that is why we have placed this salt bridge. Now rest of the detailed discussion we will do later. Right now, just think salt bridge is given so that the neutrality of both sides is maintained. It is not that positive charge generated in the left or more negative charge is generated in the right. That we do not want. Okay. So connected by a salt bridge to provide an electric contact between the two solutions without allowing them to mix with each other. The two electrodes, that is zinc and copper, they are connected by metallic wire, and now this wire should be such, not just any wire, the wire should be such so that it can conduct electrons, okay, with a provision of ammeter and a switch. So ammeter must be present. Sometimes voltmeter is also there, which measures volt. It is actually ammeter or voltmeter, any one of these should be present. And there should be a switch which opens or closes the circuit. Now, once the switch is in on position, fine, following processes will start occurring. If it is in off position, nothing will happen. But if it is in on position, then only electron movement possible. So Zn atoms from the zinc electrode, it will be converted to Zn2 plus, and Zn, where oxidation is occurring, that is called anode. In anode, oxidation occurs. So it will gradually diminish in size because Zn is gradually converted to Zn2 plus. As the cell is operating, it will diminish in size. Concentration of Zn2 plus will increase in the left half cell compartment. Now, because of the production of electrons at the anode, so it is also called negative electrode. So this process will occur. Zn will be converted to Zn2 plus and electron, two electrons. The electrons generated at Zn electrode, they will travel through the external wire and there will be a reading observed in the ammeter. Now this process will continue and the electrons will move towards the other side, enter the copper electrode where they combine with Cu2 plus ion. So this Cu strip that is dipped in CuSO4 solution, in this interface, the electrons will be coming through this electrode. Now the electrons, they will interact with copper 2 plus and they will reduce it to copper. So what will happen as a result of this reduction to copper metal, the size of copper, there will be deposition of copper on the copper strip. The electrode at which reduction occurs, that is called cathode. It is also known as positive electrode. It will gradually increase in mass because of production of copper metal. And obviously, the concentration of Cu2 plus ion in this solution, that will decrease because they are gradually converted to Cu. So this is happening in the other side. Now the role of salt bridge, if we carefully observe, see, as I have said, gradually the amount of Zn2 plus will increase. So here positive charge will increase, and in the left hand side Cu2 plus is gradually decreased. That means here negative charge will increase. Fine. Now the electrons move through the wire, leaving the unbalanced positive charge in the left compartment. Now as I have said, there is presence of KNO3 or NH4NO3 or KCl, this type of strong electrolyte. Now strong electrolyte, there is presence of cation and anion. As there is high amount of positive charge, so these anions, they will come towards this side and they will combine with this Zn2 plus so that positive, extra positive charge is neutralized. Similarly, the cationic part of the electrolyte, they will combine with this excess, that is, they will decrease this excess negative charge, that is the deficiency of positive charge, that will be maintained by this K plus. So in order to maintain neutrality of charge, negatively charged ions in the salt bridge, it will migrate into the anodic side, which is left hand side. A similar but reverse situation is found in the cathodic cell, that is in the right hand side compartment, where copper 2 plus ions are being consumed gradually. So there is lack of positive charge, and that is maintained by the migration of K plus. Basically here Cu2 plus ions will be gradually consumed, and if you have started with CuSO4 solution, obviously the amount of SO4 will be very high, and this K, it can neutralize this excess negative charge. So this is the role of, in a simple way, this is the role of salt bridge. Now details of this electrochemistry, that is basically present in another unit which is in class 12. So here we will just have initial idea about galvanic cell, especially Daniell cell. because it is all about the redox reaction. That is the purpose. What type of redox reaction is actually occurring here. So this topic is basically redox reaction and electron processes, but the details of electrochemistry that we will study in class 12 in electrochemistry chapter. Now we will come to electrochemical series. Remember what we have said in the first two experiments we have seen. In the first experiment, zinc strip is dipped in copper sulfate. So there we have proved that Zn has more tendency to donate electron compared to copper. And then we have also done another reaction where in AgNO3 solution we have dipped copper strip. And what we have seen, gradually Ag plus is converted to, that is Ag plus is reduced to silver and copper is gradually oxidized to copper plus. That means now copper is donating electron towards silver plus ion. But reverse reaction is not possible. So it proves that copper has more tendency to donate electron towards Ag. So for these three metals, if we see this order, maximum donating tendency or reducing tendency, that we will see in case of Zn. Then the next reducing tendency we are getting in case of copper, and for silver it is the minimum. Now the flow of current is possible only if, that is flow of current means the cell that we have just discussed, their flow of current is possible only if there is a potential difference between the two electrodes. Now the potential associated with each electrode, that is known as electrode potential. So for each system there is separate electrode potential. For Zn2 plus Zn system there is one electrode potential. Then we have copper 2 plus copper, another redox couple, there is another electrode potential. Then Ag plus Ag, another electrode potential. Fine. So if you know the electrode potential of all these systems, just looking at the value, you will be able to predict which species will be having more tendency to reduce the other species. If the concentration of each species taking part in the electrode reaction is unity, 1 molar, and if it is there is any appearance of gas, suppose you have taken H plus, instead of taking metal, suppose you have taken H plus, then H plus is converted to hydrogen. So in this case, obviously there is production of gas. So in those cases, if any gas appears in the electron, it is confined to 1 atmosphere. So the concentration is unity, and if it is gas, it is confined to 1 atmosphere. So if you are maintaining this type of concentration and you are doing the reaction at 298 Kelvin room temperature, then the potential of each electrode, only under this condition, the potential that you are getting, that value is known as standard electrode potential, and it is expressed as capital E naught. So it is a standard condition. Now there must be some common condition, otherwise how you will compare different couple? Because if you are doing, suppose if you are measuring the electrode potential for Zn2 plus Zn couple in one situation, one condition, and you are measuring copper 2 plus copper in another experimental condition, obviously you cannot compare. So for all the system, all the redox couple, the conditions must be same. So this is the condition, and if you maintain this, the corresponding electrode potential will be called standard electrode potential. Now the thing is, when you are trying to find a value, obviously there should be another couple, and this another couple, that must be constant for everyone. So if you are measuring the electrode potential for Zn2 plus Zn couple, then it should be combined with that particular common system. Then when you are measuring copper 2 plus copper redox, electrode potential, then it should be also connected to the same. And for silver plus silver also, it should be connected to the same. Then only you can compare all these three. Because single redox couple, you cannot construct cell. When you are constructing cell, there must be two compartments, there must be two different systems, right? So this common system is basically, by convention, what we take standard electrode potential of hydrogen, and that is called in short SHE, that is standard hydrogen electrode. And by convention we consider its value as 0. So when Zn Suppose you want to measure the value of Zn2 plus Zn couple. So you have to combine it with She. Suppose you want to measure Cu2 plus Cu, the corresponding electrode potential value. You have to construct the cell with She. So She is common, and the other part you are changing. So for each time, as it is 0, the value from the voltmeter that we will get, that value will directly give you the electrode potential of that particular system. So in this way, for several systems, if we do the experiment, then the corresponding data we collect in electrochemical series. And so in this way, once you see the electrochemical series, you will be easily able to predict. Suppose you are comparing two systems. From the value, you will be able to predict which system will be having more tendency for reduction. So standard electrode potential is obtained by measuring the voltage when the half cell is connected to She, obviously under standard condition. And this value is 0. So whatever other species you are attaching with it, connecting with it, from the voltmeter we can get the value. So details, as I have said, it will be discussed in electrochemistry, which is in class 12. So in this way, the data that you will get, that is presented in electrochemical series, it is also called activity series. It is a list that describes the arrangement of different elements. Different element means, suppose as I have said, Ag plus Ag system, then Zn2 plus Zn system. So these are the different elements in order of their increasing electrode potential values. The series has been established by measuring the potential various electrode versus standard hydrogen electrode. Now, this electrode potential value for each redox couple, that is actually the measure of relative tendency of these active species in the process to remain in oxidized or reduced form. So suppose if the E0 value, that is in the electrochemical series, obviously we will see after some time. If you look at electrochemical series, you will see there are some values that are negative. So H plus is the standard. With respect to H plus, that is 0, some values are negative. So when with respect to H plus, you are getting some negative E0 value, it proves that it is stronger reducing agent compared to the redox couple H plus H2. See, again the oxidized species is written first, then oblique, then the reduced part, which is H2. Now, if the value is positive, that means it is weaker reducing agent compared to this system. Now what it means actually, so suppose H plus H2, suppose negative E0 value, that is actually observed for Zn2 plus Zn. Now in the medium, if we have both these species together, what will happen? Zn will have tendency to feed electron to H plus. So it will donate electron to reach H plus and it will reduce it to hydrogen. But if you have taken some couple which is having positive E0, then what will happen? Now H2 will reduce that species. Okay. So that is it is written that it is weaker reducing agent compared to this. Now H2 will be the reducing agent if the value is positive. The standard electrode potential, they are very important because we can get many information just from this series. Just look at the value, you will be able to understand. You'll be able to gather many informations. So how it looks? It looks like this. Though in different books, sometimes the positive values are written below H plus H2 system. Sometimes positive values are written in the upper side. So in this case, you can see all the positive values that are written above this system. And all the reactions, there is a particular convention we have followed, and that convention is it is written as if every time reduction is occurring. Though the reverse reaction may occur, but one common pattern is followed, and that common pattern is it is in the reduction form. So see, all the species they are in plus form, then electrons are added, it is converted to the reduced form. Similarly, if you have started with 0 state, then after electron feeding, it is converted to Cl minus. Okay. So for all this system, though there are some non-metals also, but right now, if you just focus on metals, it is enough. So for the positive values, just look at this one. If you look at copper 2 plus, so if you have taken these two systems together, as the value is positive, so it means that copper will have tendency to feed electron to H plus and itself will be converted to Cu2 plus. But if you choose any species from these negative values, suppose you have, sorry, I have said the reverse side. Sorry, I'm just trying to say, when you have chosen any species from the positive side and you are coupling with H plus H2 system, what will happen? Now hydrogen will be acting as reducing agent. But if you choose any system from these negative values, now that system, suppose you have chosen iron 2 plus iron system, in that case Fe will be acting as reducing agent. It will feed electron H plus and H plus will be converted to H2. Similarly, if you choose any species, suppose you have chosen Mg2 plus system and you have chosen Mg Fe3 plus system. So obviously now Mg will feed electron to Fe3 plus and Fe3 plus will be converted to Fe2 plus, because compared to this value here, this value is negative. So negative values compared to standard, this is standard because it is 0. If it is negative, it will be more stronger reducing agent. So see, as you are moving upper side, stronger oxidizing agent you can find. As you are moving down, it is weaker oxidizing agent. But when you are moving down, it is basically stronger reducing agent. That means lithium is having, as it is having the maximum negative value. So you can say among all these species that you are seeing here, it will have maximum tendency to feed electron to any other species when they are in their oxidized form. Okay. So this is the significance of electrochemical series. Now based on this, here we have a problem. Consider the following reduction process. Zn2 plus accepting electron, it is converted to Z. Now see, all these reaction patterns, they are maintaining the same pattern. The same pattern means all are written in reduced form, as if everyone is accepting electron and they are converted to their reduced form. Now if you look at the values, minus 0.76, 2.87, basically you can also find all these values here. See, for Zn it is minus 7.76. Then what other values we have? For Mg minus 2.36, for nickel 0.25. So here you can see for nickel there is little difference. This is the value for nickel. For Mg, so you can also get the values here. In question obviously it will be given. So from these values you have to predict the reducing power of the metal increases in which order. Now you just have to choose among these values which one is maximum negative. So maximum negative is this one. That means calcium will have maximum tendency to reduce. After that, which one is less maximum negative? That is basically Mg. So after Ca, it should be Mg. Then we have Zn2 plus Zn and nickel. So this is more negative. So it will be next Zn and then it is A9. So this is the reducing tendency. So you can get it in option 2. So option 2 will be the correct option. See, it is very easy. Just from the values you just have to compare which one is most negative and then accordingly you can arrange. So option 2 is the correct option. Now this chapter is basically complete. We are ending it with electrochemical series, but as we have some time left, we will discuss one question. In basic medium CrO4 2-, see, it is not dichromate, it is basically chromate, though here also oxidation state is +6. So CrO4 2- oxidizes H2O3 2- and H2O3 2- converted to SO4 2- and itself changes into CrOH 4-. So this is obviously the oxidizing agent. There is no doubt in that. Cr, it is in plastic oxidation state, it will always be acting as oxidizing agent, and H2O3, that is basically reduced to, oxidized to SO4 2-. So here it is basically +6, and you can also calculate the oxidation state for sulfur, but we are not going to that, because here the balanced equation that we have to finally write, I will do that by half reaction method. Okay. So in basic medium, this reaction is occurring, CrO4 converted to CrOH whole 4 minus 1 and H2O3 2 minus converted to sulfate. The volume of CrO4 2 minus that we have to find in ml, molarity given, and the volume and molarity for the other species that is also given. Okay. So if you know how many moles of CrO4 2 minus is reacting with how many moles of H2O3 2 minus, then only you will be able to do the final calculation. And how you will be able to know that? You just need to know what is the balanced equation. Then only you will be able to understand how many moles of CrO4 2 minus is reacting with thiosulfate ion. Fine. So I will write the equation here. CrO4 2 negative, it is converted to CrOH, just one negative charge. Now it is occurring in the alkaline medium. Next, what we will do, number of oxygen both sides same, but number of hydrogen not same. So that is why I am writing here 4H plus. But this is basic, so I have to add 4HO minus both sides. Now from this part you will get 4H2. Next, if you see total negative charge in the left hand side is only 2, but in the right hand side it is total 5. So that is why I will add 3 electron here. Now both side number of charge is same. Now the same type of, that is for the other equation, if I write it, it is H2O3 2 negative, it is converted to SO4 2 negative. Look at the number of sulfur, it is 2, so I have to write 2 here. Look at the number of oxygen, it is 3 in left hand side but 8 in the other side. So that is why I have to write, I have to make oxygen both side. So that's why I have to write 5H2O. But as I have added 5H2, I have to write 10H plus. It is basic medium, so I also have to write 10HO minus both side. Now from this part, you will get 10 water molecule. What about the negative charge? Total negative charge in the left hand side is 2 plus 10, total 12 negative charge. But in the right hand side, it is 4 negative charge. So that is why we have to add 8 electrons. So finally, the equation that we are getting is 2O3 2 minus. There is 10HO. In the left hand side, 2SO4. 10H2O, 5H2O, total 5H2O. And 8 electron. Now we have obtained the halves equations already. Now see, this reaction we have 3 electron and the other equation we have 8 electron. So we know in this method when we balance it, we have to multiply it with 8 and this equation we have to multiply it with 5. But don't waste your time. This much information is enough. You just have to know which is the number you have to multiply. But once you multiply, just focus on this species. What you get? You get 8 CrO4 2 minus, and from this side you get 5H2O3. That means these two are equivalent, right? So this much information is all we need. Now from this you can write that here it should be 3. So it is 3. So now I can write that 3 moles of H2O3 2 minus, that is reacting with 8 moles of CrO4 2 minus. That means it is also true for millimoles, because both sides it will be millimole then. Now here it is 40 into 0.25. Now we know when we multiply volume in ml and molarity, we get number of millimoles. So if you multiply 40 and 0.25, it is basically 0.25 means what? 1 by 4. 40 into 1 by 4 is 10 millimole. So from 10 millimoles of H2O3, it should react with 8 by 3 multiplied by 10 millimoles of CrO4. Now millimoles of CrO4 that we do not know, but this is 80 divided by 3 millimoles, right? Now we know only the molarity. We know only the molarity, but we do not know volume. Suppose volume is VmL and this is 0.154, but that is equal to, this is the number of millimoles, but that is equal to 80 by 3. So from this you will get the value of V, which is basically 173.16. So this is the final answer in ml. So in this equation you just have to balance the, you just need the balanced equation, but full balanced equation you don't have to write. Once you manage the half reactions, that is once you balance the half reactions individually, then you know to equate the number of electrons what number you should multiply. So with H2O3 system you have to multiply 3. So 3H2O3 2 minus will be present in the final balanced equation, and this is equivalent to 8 moles of CrO4 2 minus. Okay. Next, another problem. In neutral or faintly alkaline solution, 8 moles of permanganate anion quantitatively oxidize thiosulfate anion. Again, we have H2O3 2 minus. It is neutral or faintly alkaline. It is asking, in this medium, 8 moles of permanganate quantitatively oxidize H2O3 2 minus anion, and it produces X moles of a sulfur containing species. That means H2O3 2 minus, it will be oxidized to some sulfur species obviously because it is containing sulfur. But which species it is? It is SO4. So this information you previously you have to know that permanganate, we know this is very strong oxidizing agent, and sulfur maximum oxidation state possible is SO4. So when H2O3 is reacting with KMnO4, its fate will be SO4. So in this question, it is basically asking that 8 moles of KMnO4, it will produce how many moles of sulfate? That is the question. So if we want to know this, we have to balance the, we need to know the balanced equation. But remember, it is neutral or faintly alkaline solution. And in oxidizing medium, MnO4 minus, its fate is Mn2 plus. But when it is neutral or faintly alkaline, its fate is not Mn2 plus but MnO2, where the oxidation state is +4. But we are solving in the half reaction method. So what we will do, MnO4 minus converted to MnO2. So to balance the oxygen, we have to add 2H2O. So when you are adding 2H2O, we have to add 4H plus, 4HO minus, both sides. So it is producing 4H2O. Now look at the negative charge. You have only one negative charge left hand side, 4 negative charge in the right hand side. So you have to add 3 electron. Now come to the other reaction, H2O3 2 minus. To balance the sulfur, you have to write 2 here. Next, you have to balance oxygen. So you are adding 5 water. Now when you are adding 5 water, you have to add 5H plus. It is alkaline medium, so 5HO minus both sides. Now from this part, it is 5 water molecule. Look at the negative charge. Total negative charge in the left hand side, 2 and 5. It is 5HO minus. Let me check once. 5H2, sorry, it is 10. 10. This is also 10. 10 water molecule. Now when it is 10 HO minus, 10 HO minus 2, that means total 12 negative charge, and here we have total 4 negative charge. So we need to add 8 electrons. So finally, if I write it clearly, it will be H2O3 2 minus 10 hydroxide ion. In the right hand side, basically the same thing we have just done in the previous question. 5H2O and 8E. So see, you have already obtained your answer because here 3 electron you have to multiply it with 8. Here you have 8 electrons, so you will multiply it with 3. That means in the final reaction, final balanced equation, you will get 6 SO4 2 minus in the balanced equation. I'm not writing the balanced equation because that is simply you don't need to write the balanced equation. You just need the what is the number with which you will multiply this equation both sides. So you are multiplying the MnO4 equation with 8. That means in the final equation, 8 MnO4 minus will be in the left hand side, and this is equivalent to 6 sulfate ion. And in the question it is asking 8 moles of permanganate ion quantitatively oxidized thiosulfate, but it is not asking the number of moles of thiosulfate. It is asking thiosulfate ion will produce X mole of some sulfur containing species, which is nothing but sulfate. So answer should be 6. The magnitude of X is 6. It will produce X moles of sulfur containing product. So it means it will produce 6 moles of sulfate. Okay. So answer is 6. So we are at the end of the session. Thank you for listening. And this chapter is completed.